Hello, my name is Grant Rushlow, and I research Township 42 North, Range 8W, also known as Lenroot, Wisconsin. And the reason I wanted to do this specific one is because it is home to the American Birkebeiner cross-country ski venue. And they have a large snowmaking operation there, and I wanted to see if that snowmaking operation had any sort of effect on the water table. All right, so getting into it right away, here's the topography map that I made of this township. So there's a few features that I want to point out. Right away, we're going to see this valley going up and down toward from the northeast side down to the southwest side. And if you look at the elevations here, the elevations are going to be much higher in this northeast end than they are down here. So that's going to indicate water flow direction going from that northeast down to that southwest in the middle of that valley there. Another thing I want to point out is these very steep ridges on either side of that valley. Those are going up in elevation as you go farther away from that valley, so you're going to have another water flow direction going down into that valley. One final thing that I like to point out is this cone of depression, or apparent cone of depression that we have here. This is honestly something that's questionable. It could be a cone of depression in this area due to high use, or it could just be a lack of data. And this is more likely just following alongside this river that goes through the valley, as that's probably the lowest point there. Like I said before, here's a representation of the groundwater flow in that area. As you can see, a majority of the groundwater is flowing down through the valley, and then we're also having additional groundwater flow into that valley. So next up, I'm going to be going into the cross section of this area. First thing though, I wanted to point out that this line that I've drawn here is the area that I'm going to be cross cutting. And I chose this area because I think it's a good, nice representation of that valley. And it also intersects with a large amount of wells that will give some good data about the water level. All right, so here's a cross section. First things first, I want to say that the surface elevations that are drawn here were drawn with some help given from tools in the Wisconsin Geology GIS map that we had as a resource. And that was very helpful, especially in an area this complicated. So yeah, that was nice. So first things here is that we can see these flow arrows here representing this downward flow. If you notice the water table on this that I found from obviously taking the water levels of these various wells along the area, it's roughly following the topography of the land here. So that water is going to flow from higher head to lower head down into the middle of that valley there. Now, if this were in 3D, this water that's in the valley would be flowing towards us, actually. Other than that, the geology in this area really isn't too crazy, especially within this aquifer that they use. And we're going to discuss that more in the next slides here. So starting off with the bedrock here, honestly, there isn't a whole lot to talk about. Considering this bedrock isn't a major component of the aquifer, as none of the wells in the area even hit bedrock. They're all in the sediment above it. But anyways, the bedrock in the area is going to be composed of the powder mill group, more specifically the Mellon complex, which is a group of extrusive igneous rocks, mainly composed of basalt with a little bit of rhyolite. And pretty much all this is doing is serving as that impermeable bottom layer for the aquitard that lies above it. And just a couple more figures to go around with that bedrock geology. We can see up over here where our township is that it pretty much lies dead on this PKL group, which is that powder mill group that I was just discussing. And it also lies along the mid-continental rift, which is where these igneous formations came from in the first place. All right, so now onto the actual aquifer. This groundwater is going to be hosted by a very large amount of non-consolidated glacial sediment. As we can see in this map here, you can sort of see the same valley type figure you see in the original map. So first thing I'd like to point out, along the sides here, this unit CL and unit CH. These are pretty similar. Both of them are very poorly sorted, sandy to gravelly type glacial till deposits that were left behind by glacial melt retreat. And then in the middle here, we see this SU unit. And this is going to be that valley that was carved out by basically glacial outwash. And you can see this the Namakagon River is what remains of that outwash stream today. So that's pretty interesting. Also, another cool thing I like to point out is that there were some smaller sediment sizes, like clay, like more clay-rich sediments down or the towards the bottom end of the river, and some more sand-rich sediments up towards the top end of the river, which is what you'd expect to see. All right, so I was able to find out some water quality information from this nice resource from UW Stevens Point. So generally the water quality here is very good, especially for as exposed of an aquifer as this is. This is likely due to the lack of major industrialization. The town Sealy that I was talking about it's a pretty small area overall. It's a small town, not a whole lot going on there, so we don't really have a whole lot of industrialization or like crazy agriculture that's gonna dump a bunch of chemicals into the water. Um, the main water quality standout issue appears to be with bacteria presence. This one was stuck out as a bit higher than others in its area. And this is very likely due to the shallow nature of the aquifer. And another potential cause of this would be some fecal contamination. That's very possible with like these bacteria outbreaks that we see sometimes. It wasn't like I wouldn't call it an outbreak necessarily, but standout bacteria presence, I guess. Another thing that I'd like to note is that PFAS isn't really tested for on that Stevens Point website or a whole lot in this area, but there are other resources that point to shallow aquifers, especially in northern areas like northern Wisconsin and upper Michigan, having a very large growing issue with PFAS. So this would be really interesting to look into in the future, I think. All right, talking about the sustainability of this aquifer, generally, it's really not going to be a big issue in this area. In terms of quantity, there's plenty of water to go around. Our water table is still very high generally. There's not a whole lot of people drawing from it, and the recharge is pretty constant as well as local. So quantity is not an issue. Quality also not an issue. As you saw on the last slide, the water quality is exceptionally good, even for the area it's in. So yeah, even when we talk about that cone of depression on the topography map, that's even questionable if it even exists. That could just be some misinterpreted data, lack of data rather. Just like getting really close to that river, there might even be another topography line just connecting alongside that river at the lowest point. Also, with the Birkebein or snowmaking operation, as I've concluded, it does not really have a large effect. This is because the water is only going to be drawn seasonally, really, so the water has plenty of time to recharge. And that's going to be about all I have. Here's the sources I use compiling this information all here together. Yeah, thank you for listening.